Dear participants, welcome to 7th International Symposium on Multidisciplinary Studies and Innovative Technologies. We are in session 10.1 now, and we have 10 papers that will be presented in this session. Each participant will have 10 minutes to present their studies. First of all, our Congress is supported by IEEE Turkey section, and on behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress. Let's start with the first paper. The title of the paper is Generating and Evaluating City Building Facades Using Artificial Intelligence. Are the authors of this paper here? Are the authors of the first paper here? I guess they are not here. Let's go on with the second paper. The title of the paper is Technical Analysis of Stock Market Trends Using LSTM for Price Prognosis. Are the authors of this paper here?
Hello. Yes, we are here.
Okay, if you are ready, you can share your screen.
Sure. Is my screen visible?
Yes, visible.
All right.
You have 10 minutes to complete your presentation.
Sure.
We can't see your screen anymore.
I think there seems to be a problem. We are sharing the screen again.
Okay, we are waiting for you. If there is a problem with your screen, you can present later. Or
No,
if you are ready.
no. Hello. We are presenting now. Can you tell us if our screen is visible now?
No, we cannot see your screen.
Just a second. Trying again. There seems to be some technical glitch.
Please press the share screen button.
Is it visible now, sir?
And now it is visible.
All right. So can we begin?
You can begin, but we just see a white page now.
Yeah.
We only...
Yeah.
Okay, yes.
Yeah.
Now it's good. You can start.
All right. Greetings of the day to one and all present over here. We are here to present our paper, Technical Analysis of Stock Market Trends Using LSTM for Price Prognosis. The stock market is a financial marketplace where publicly traded companies' stocks are bought and sold. India, during its race to becoming the fifth largest economy, and especially after becoming one, has been seen a massive boom in its stock market. Hence, it holds a great potential of giving phenomenal returns on invested capital. There are a lot of investors in India, but unfortunately, a mere 16% of them are only profitable. The volatility and dynamic nature of the stock market is a major issue for common man to invest in stocks. Hence, there is a lot of paranoia amongst investors, especially individuals who are losing their money when invested in the wrong stocks or at the wrong time. Insights about the future prices of the stocks or a particular sector prior to investment would help to solve this problem to a certain extent. Our related work includes some papers in which we studied about the price prediction that they have done for the stock market, and a majority chunk of them have been observed for the New York exchange, the Nasdaq, but very minimal papers were researched on the Indian stock market. So we are our case study, our methodology is to implement the algorithms on the Indian stock market, the Indian stock market data, which we are borrowing from the NSE, the National Stock Exchange of India, and we will be working on them. Moving on, I'll quickly tell you about the research methodology. Data collection, where we get our data set, we refine it, which is the data pre-processing part. Then we do the feature engineering, where we understand the features or the attributes of the data set, where we can harness the information for our use. Moving on, we go to model selection. We look out for the best possible machine learning approaches to the problem, and we shortlisted 4 such algorithms for our approach. Then we trained the model, then evaluated it and refined it to increase the accuracy. The stocks that we are working on are borrowed from Nifty 50. The stock market can be measured by indices such as Nifty and Sensex, which track the performance of a group of majorly publicly traded companies. The Nifty 50 is a stock market index in India that is composed of 50 largest and most liquid companies listed on the National Stock Exchange of India, or NSE. It represents the overall performance of Indian equity market and is considered a benchmark index for Indian equities. So we can see there are some sectors which are presented over here, which make up the Nifty 50 index. Moving on, we have the implementation, where we have implemented 4 machine learning algorithms, which is linear regression, random forest regression, KNN, and LSTM. So this is the performance matrix that we were getting. This is the result table of the performance matrix, where for every algorithm, we calculated the RMSE, root mean square error. Then we calculated the MAE and then R square for every algorithm. And then we found out that LSTM performs the best in these 4 algorithms. So these are the results. So you can see in the linear regression, the actual data which is marked in yellow and the predicted data that is marked in green, it shows a variable change and does not predict the stock properly. Moving on to random forest regressor, again we can see the predicted data is nowhere in comparison to the actual data. And same goes for k nearest neighbors. Only some of the points are coinciding with the actual data which is presented in yellow, but the predicted data which is presented in green is like it has only some points where it is coinciding. So we come to a conclusion wherein LSTM, which properly coincides with the actual data. As you can see, the orange line and the green line is where the actual data and predicted data are actually coinciding. So we can come to a conclusion wherein LSTM gives the best results from all these 4 algorithms. Moving on, this is the algorithm comparison table. So we selected 14 best stocks from all the Nifty 50 sectors, and then we found out that we were getting the most accuracy in LSTM, as I mentioned earlier. And in every stock we are getting above 90%, except for 3 stocks, that is Bajaj Finserv, Bajaj Finance, and Iker Mode. So coming to our conclusion and future scope, we have observed that although LSTM is a very useful method because it is analyzing the time series data in as we know that stock market is a time series analysis. So LSTM performs very nicely on them, but only for 3 stocks we found out that they did not give a higher accuracy. It is at 63, 72, and 68% respectively. To overcome that, to make a better strategy, we are now having algorithmic trading as our future scope, wherein we'll be creating a reinforced machine learning algorithm where it will where the accuracy will be optimized for all the sectors and for all the stocks. So that's it for our presentation. Thank you so much for giving us this opportunity.
Yeah, thank you very much for your presentation. Dear participants, do you have any questions about this topic? As I can see, there are no questions. Let's go on with the next paper. The title of the paper is FPGA-based secure channel design in power distribution systems. Are the authors here? I guess they are not here. Let's go on
Hello.
with the next. Are you here?
Yeah, I'm
Okay.
here.
Okay,
Am I audible?
you can share your screen.
Please give me a minute.
We are waiting for you to share your screen.
Is my screen visible?
Yes, we can see and you can start.
Yeah. Hello, everyone. Good afternoon to everyone attending the session. My name is Kesav Jairam. I'm a recently graduated student from IIITM Kurnool, India. I'm here to present our work, FPGA-based secure channel design in power distribution systems, which I did during my final year of my BTech under the guidance of Dr. M.A. Bas. So this is the outline of this presentation. First, I will give basic insight into cybersecurity in modern power grids and cite few cyber attacks that happened in the past. Then I will discuss about the insecure channel we have developed for demonstration purposes. In the next section, the cyber attack that is performed on the insecure channel is explained. In the coming session, methodology of the FPGA-based countermeasure we have proposed to secure the channel is discussed, and then the coming session goes through different ways in which this countermeasure is implemented. Coming to the objective, to meet the modern world's power supply demands, the introduction of networking into power grids became necessary. So this gave the cyber attackers an edge on trespassing into the power grids. So the objective of this work is to provide an FPGA-based countermeasure that can detect false data injection attacks on power grids using advanced encryption standard and secure hash algorithms. So the countermeasure we are proposing will introduce cybersecurity concepts like confidentiality, integrity, and authenticity to the data being communicated inside the power grids. The figure here shows the basic overview of the distribution service operators network, which can be called DSO. This can be divided into the office network, which communicates with the outside world through the internet, and the process control network, which consists of the major functional blocks like SCADA systems, PLCs, sensors, and actuators, which actually control the power grid. Attackers may try and exploit the vulnerabilities present in the office network of the DSO and gain access to the inner parts of the system. From there, the attacker can compromise substations or field devices, potentially leading to a blackout. So once access over some or whole of a process control network is gained, the attacker can launch different attack scenarios. In the example shown here, 80,000 consumers were disconnected from the grid during the attack on Ukraine power grid in 2016, as attackers were able to control this on multiple substations. So another such cyber attack was against UHBVN in 2018. Billing data of 4,000 customers in the automatic meter reading system inside the power grid was targeted, and the attackers demanded 1 crore in Bitcoin to retrieve the data. In Kudankulam nuclear power plant, only one computer connected to the administrator network's internet had been targeted to launch a malware attack. However, critical systems were reported safe as they were contained in an isolated network. Because of such incidents, securing the channels that connect to these critical systems became necessary. So coming to the insecure channel implementation we have developed. So we have UPCs connected to the same local network to demonstrate the working of a prototype we developed using an Arduino-based testbed, hereafter called mini PDS. In this, a transmitter PC TX hosts a HTML file over Ethernet. The receiver PC RX connected to same network makes a HTTP request to TX, access the 4 control bits hosted in the HTML file at TX. TX then responds to the request and sends the control bits to RX. These bits are then used by RX PC to control the Arduino pins the LEDs are connected. So we can see here that the sequence 1011 is hosted by the TX in the HTML web page. So, and the LEDs connected to the RX PC are glowing according to this sequence 1011. So now I'll explain the methodology of the data injection attack I have performed on this insecure channel. This is the procedure followed to perform the FDIA attack using ARP cache reasoning technique. First, in the ARP cache table of the RX PC, the IP addresses and MAC addresses of TX PC and attacker's PC are interchanged. Then the HTTP request to TX made by RX will then be routed to attacker's PC. Then the attacker's PC is made to respond to RX PC with false control bits. So this slide demonstrates the effects of this FDI attack on the insecure channel. We can observe the web page was loaded with false control bits 0100 hosted by attacker's PC after the attack. And thus the LEDs are glowing according to those false control bits after the attack. Coming to the secure channel implementation now. This figure explains working of the algorithm we proposed for securing the channel. Instead of sending the control bits directly over the Ethernet, we process the control bits using 128-bit AES encryption and SHA-256 algorithms, and the outputs of both encoded in hexadecimal format are concatenated, and this 384-bit hex text is transmitted over Ethernet at TX. Sorry, this 384-bit hex text is decoded at RX, and then the first 128 bits are to the 128-bit AES decryption algorithm to produce a 4-bit output, which is hashed again using SHA-256 algorithm to produce a output hash Y. So this output hash is compared with the last 256 bit of the 384-bit input we have given to the receiver, which is X, and then they should be equal when the data is not manipulated. Based on this comparison, the algorithm will decide whether the 4-bit decrypted output is trustworthy to enter the mini PDS. In the coming slides, I will briefly explain the working of both algorithms. So this figure shows the working of AES encryption and decryption using a 128-bit cipher key. Encryption part takes 128-bit plain text as input and produces a 128-bit cipher text. So the reverse process decryption part takes 128-bit cipher text as input and produces corresponding 128-bit plain text. Now coming to SHA-256, the figure shown on the left explains the working of SHA-256 hash function, which takes in a 512-bit message block to produce the 256-bit intermediate hash digest. So the figure on the right explains the whole SHA-256 algorithm, which uses the hash function shown on the left recursively to all the 512-bit blocks of the message to produce the final hash digest. So the figure at the top of this slide shows the part of the countermeasure implemented at TX PC. The bottom figure shows the RTL schematic of the logic that needs to be implemented on TX FPGA. So this logic takes 4 control bits as input and produces a 384-bit hex text as mentioned before. So the 384-bit will be sent to RX PC through Ethernet. Now the figure at the top of the slide shows the part of the countermeasure implemented RX PC. The bottom figure shows the RTL schematic of the logic that needs to be implemented on RX FPGA. So this logic takes the 384-bit output from TX FPGA as input and produces the 4 control bits to mini PDS along with an additional bit called bit, which indicates if the data received is manipulated or not. This first 128 bits of this input is to produce a 4-bit decrypted text. This decrypted text is then used to process an intermediate 256-bit hash digest. If both the hashes are full, then the flag bit will be set to 0, otherwise it will be set to 1, which indicates the attack. This figure shows the complete implementation of the secure channel using the 2-way FPGA boards. The logic explained in the previous 2 slides is implemented on the FPGAs corresponding ends to secure the channel between TX and RX. The message received from the Ethernet network at RX will not be allowed until it is checked if it is valid or not. This slide shows the effect cyber attack on the secure channel. The same process was followed to perform an attack secure channel We can observe that the last hex digit page is changed from 7 to 6 after the attack in the body. We can see the comparison between the mini PDS outputs inside secure and insecure channels before and after attacks. So there is no mechanism to detect the FTIA attack in insecure channel. Hence, we can never know if the data received is trustworthy or not. But the outputs are not allowed to mini PDS in the secure channel, and the attack is indicated by the flag bit, allowing the switching of operation of critical systems in the power grid to manual mode until recovery. These are the equipment and tools used as part of this work. All the implementations in this work are implemented on Digilent's Zinc 7000 FPGA, also known as Z-board, using Xilinx platform. Now we will discuss the other implementations of the same algorithm.
Sorry, your 10 minutes is finished. Please try to summarize and conclude.
Yeah, I'm almost at the end.
Okay.
This is the Zinc 7000 FPGA consists of 2 ARM cores. This is coprocessor based implementation using 1 ARM core of Z-board at TXPC. This is implementation was previously explained in the previous slides. The algorithm it takes is realized as hardware using Verilog HDL, and AXI Lite slave interface is created around this logic. The Cortex A90 core is used to communicate with the TXIP. This is similar implementation at RxPC. This is the coprocessor based implementation using 2 Cortex cores of the Z-board. The AES encryption and SH algorithms are realized individually as hardware, and AXL8 interfaces are created around each of these logics separately. Then the Cortex A90 core is used to communicate with AES IP, and A91 core is used to communicate with SSH IP. So this is similar implementation at RX side. The decrypted output from this IP is stored in shared memory region, which is fed as input to SH IP by Cortex A91 core to produce the final output. This is the Vivado IP integration diagram for all the software implementations. Both AES and SH algorithms are written in C language, and programs are run on the ARM cores according to the implementation used. This table summarizes the working of software-based implementations, both single and dual core, at TX and RX, and job of each core is represented in each implementation. So at RX, the output of AES block must be fed as input to the SHA block. So due to this dependency of SHA block on AES block's output, parallelization using 2 Cortex cores is achieved differently in dual core implementations at RX. So this is done by imitating a pipelining-like mechanism using the 2 Cortex A9 cores, in which the both cores communicate using a shared memory region. So this table summarizes the synthesis and implement results using Z-boards at TX and RX pieces. We can infer that software-based implementations are giving outputs with significantly less hardware cost and minimal power consumption. But the latency is very significant, whereas the coprocessor-based implementations offer less latency with the increase in hardware cost and power utilization. Also, we can infer that dual core implementations give outputs with much lesser latency than the single core implementations in both coprocessor and software-based implementations. From the results shown in the previous slide, we can conclude that the hardware-based dual core implementations provided best results in terms of reduction in latency and optimum hardware and power consumption over other implementations. During our literature survey, we have observed the shortcomings of standalone implementations of AES and SHA while providing data security. Because standalone implementations of AES couldn't provide integrity and authenticity, while standalone implementations of SHA compromise the availability of the data once hashed, because the hashing process is irreversible. Hence, in this work, we have used both the algorithms, which complement each other well to provide a better solution for data security. And to summarize the work we did, we have developed an insecure channel and performed the FDIA attack on that. So then we developed the hardware implementations of the proposed FPGA-based countermeasure to secure the channel against FDIA and eavesdropping attacks. After that, we realized the same algorithm in different implementations and compared the hardware cost, power consumption, and latencies of all the implementations, and concluded the hardware-based dual core implementations offered best results over other implementations. So these are some of the references we have gone through as part of this work. Thank you for all your time. Any doubts related to the work can be resolved.
Thank you very much for your presentation. Are there any questions? Okay, there are no questions. The title of the next paper is UAV Bioacoustic Monitoring for Bird Survey. Are the authors here?
Yeah, that's me.
Okay, you can share your screen and start your presentation.
Okay, give me one moment. Okay, can you see and hear me?
Yes, there's no problem.
Fantastic, thank you. So I'm Michael Clayton. I'm part of Queen Mary University London as part of the Centre for Intelligent Sensing, and this was I'm presenting the paper to UAV Bioacoustic Monitoring for Bird Survey, and this was done in conjunction with Lin Wang. So the use of UAVs is offering a potential solution to, ecological studies and environmental science, and this approach is being used increasingly for bioacoustic monitoring of wildlife. And so audio recording systems, they offer a range of benefits over visual-based sensing. So the equipment's generally more energy efficient, it's lightweight and generally more cost-effective compared to the visual-based sensing counterparts. But one of the main challenges is that when you're using UAVs, is that there's a strong presence of noise. So, this is a culmination of, the motors, the propellers, the kind of airflow through the propellers that gives you the uplift. So this is one of the things that is one of the challenges that you have to go up against. We designed a system that essentially a low-cost audio recording system that we use with a quadcopter, in this case, DJI MH100, and we position that below the drone for the first configuration. And then for the second configuration, we reposition that system horizontally. And for each of these, we use 2 different windshields as well to kind of test what might be better. So the current state of the art, these are just an example of a couple of studies, but they use bird samples and playback for testing, which is something that we ended up adopting just so that we could test our system. But most of the state of the art primarily focuses on bird detection rate, but without comprehensive analysis of different drone hardware or microphone types to kind of understand, the noise performance and, whether there can be improvements to the signal to noise ratio without having to do as much software-based improvements. So this is the system. So the images to your right there, the top one is the vertical position, and below that is the horizontal position, to give you an idea of what it looks like in flight. So as mentioned, DJI MH100, we use the carbon fiber propeller types because this improves the flight performance. Because the standard propellers that you get with the system are plastic and they have a tendency to flex, so that creates a lot more noise. So we swap them out for better propellers so we can reduce the sound further and, as mentioned, improve flight performance. We have a Tascam recorder that has an inbuilt limiter, and we do apply that for recording so that we can avoid any potential peaks during recording. And we use a Rode NTG 4+ shotgun microphone, which has 3 filters inbuilt, but we apply one of those, and that's the high pass filter, so that we can reduce potential wind noise or air on the mic. And it has an internal power, so that means we don't have to use external power and thus, add extra weight to the drone. So we did kind of three stages. So we did payload weight versus noise. So essentially what this was to do was to find the ideal payload weight for the microphone system, and then do a general flight with that so that we can see the flight stability with the payload and its accuracy or the drone's accuracy holding its hover position, say, over a target area. And then a high altitude flight so that we could then test, okay, can it pick up bird called audio at higher altitudes, using that system. So yeah, as mentioned with the payload versus noise, we want to establish what the relationships between increasing the payload and how much this contributes to the noise output from the UAV. And for this, we set the maximum weight to 1 kilogram, and we would increment weights by 100 grams. So we'd have a tray underneath and we would increment those weights and test it. And this maximum weight was determined just purely by the recommended guidelines from the manufacturer. So for this, we use an onboard microphone and an external microphone. We found that we used the external microphone for our analysis because it gave a much more realistic depiction of what was going on with SNR. But essentially for each weight, we record a noise-only recording, so the drone in the hover state. And then for this particular one, we record a speech-only recording. That's captured with the microphone placed 1 meter away from the loudspeaker, and that's played back so we can record that separate. And then we use these two recordings to compute the signal to noise ratio. So we found that, the noise of the drone increases sort of as expected, as we were adding weight, but then we found that from about 600 grams to about 1 kilo, it begins to sort of plateau. And this could be associated to the fact that the drone, because it's a bit more powerful, it's a larger size, it's less susceptible to the increase in weight compared to, say, a smaller drone configuration. We found that at 900 grams, there was a bit of a slight change, but we recorded the experiments and we attributed this to the slight drift of the drone in front of the microphone when we were testing. And because when we film it, we can observe the behavior of the drone. And then, high altitude flight tests, we want to establish, okay, can it capture bird calls from a high altitude? So as mentioned, 2 different microphone positions, vertical and horizontal. 2 different windshields, so the Rode WS6 and Rycote Super Softy, as they're named. And the drone would hover at 3 designated altitudes that we chose at this stage, so 10, 15, and 20 meters. And similar to the payload versus noise experiment, we get 3 recordings. So we'd have a noise only, so that's just the UAV hover state. For this one, we would get bird only, so we get the bird calls separate. And then we would do a mixed signal one. So that's, the drone in flight recording the bird sounds so we can assess that. And the sound level of the loudspeaker was controlled to around 70 dB, which is basically an average of to have similar levels to bird calls in the respective environments. So this is the average. This is dependent on bird species. Some will be louder, some will be quiet, but this is kind of like an average. And just a bit more on the computation. So like I say, very similar to payload versus noise. We get, the noise only, then we get bird only, very similar parameters to the payload versus noise experiment. But the bird audio sample would consist of 33 segments, and each has a different bird species here in the, that are here in the UK. And the duration of that sample file was around 10 minutes. It gives us enough time to do enough fly time to experiment. And just for anyone who doesn't know, is the calculation there for how we get SNR. So we found that the Rycote windshield performs much better than the Rode, a little bit better than the Rode windshield, by about 4 dB improvement on that. And, we, from our assumption, from the initial 1 meter distance, and then we measure from that, we assumed the 6, we inverse Wheeler where it's a decrease of 6 dB for each doubling of distance. So we found that this was the behavior when it was in the vertical position. Horizontal position had a much lower SNR, so there was a difference around 13 dB, so so the SNR decreases. And so we found that this, similar to before, the Rycote windshield performs better than the Rode windshield by a small margin, but the vertical position performs better. So here's a comparison of just at 10 meters for this, so that's 33 feet for the vertical position. As we can see, with both windshields applied, they both capture bird call audio successfully, but there is a bit more UAV and wind noise in the low to mid frequencies when we have the Rode WS6 windshield applied. But Just to mention, some denoising has been applied to this just so that we can, just for easier analysis. But as you can see, it still successfully captures those bird calls with both windshields. And this is just an example at a higher altitude, but for like the horizontal position, it's much more susceptible. You know, the UAV and wind noise blankets most of the frequency spectrum. As we can see, there's a lot more of the harmonics, and this can be attributed to the microphone position and kind of, you know, the fact that there's an absence of bird calls because of the very low SNR, so they can't seem to penetrate through certain aspects of like maybe the rotors, that kind of thing. So in conclusion, you know, we found that the SNR is greatly improved when the microphone system is in the vertical position, so positioned under the drone, despite, you know, having airflow coming down to, you know, that gives you uplift with the drone. It doesn't seem to affect the vertical position as much as we may have anticipated, so that's good. It's performing a lot better, and that's with the Rycote windshield applied. And you know, I've given you some examples of the bird calls used in the vertical position, but at all three altitudes, it was successful at capturing bird calls. And so it verified that this hardware could be, you know, used for this application. But, you know, there's some improvement to the hardware that could be done for future work. So one improvement could be the introduction of a winch system to lower the recording system closer to the target sound source and then retract it before landing. So we can create a little small distance between the microphone system and the drone to keep, you know, to reduce the noise even further during capture of, you know, the bird call data. Another approach could be to compare the audio data recorded with this system with the audio recorded with a smaller drone configuration. We did have another a smaller drone configuration that we had done for a previous publication, and so we could potentially compare the two and see the pros and cons of each system and their approaches. So that's another direction for that. Thank you very much for your time, and I appreciate it. Thank you.
Okay, thank you very much for your presentation. I guess there is one question, right? Somebody raised hand. Ria Peshlivani.
Yeah, hello. Hi, Mikhail. I'm Ria Peshlivani from CERT. I would like to know what is the payload of this UAV system?
So its maximum is 1 kilogram, but for the recording system, that comes in at about, I believe it's 349 grams.
So it's a very small one,
Yeah.
UAV.
Oh, the UAV, it's not small. I wouldn't call it small. So it's not like if you know of like the Mavic Pro series and stuff where it's quite small. It's more the Matrix 100 is bigger than those, but I wouldn't call it really large. So I'd say probably a medium size. It's basically one of their early development drones where you can literally you know, you can change it, you can do what you want with it, but yeah, it's I would say it's about a medium size. Yeah.
Okay, because the size of the UAV and its payload, it depends for the noise that can provoke. So Mikael, can you please in the chat box send me your email?
Yeah, for sure. Yeah, no problems.
Thank you so much.
Thank you.
Okay, thank you very much for your presentation. Let's go on with the next paper. The title of the paper is Embroidered Paths for Seamlessly Embedding Sensors in Smart Textiles. Are the authors here? I guess Daniela Sofronova will present. Do you hear me? Okay, then let's go on with the next paper. The title of the paper is In-Depth Study Across Various Disciplines of the Agri-Food Retail Chain on Sufficient, Safe and Healthy Food. Are the authors here? I guess
Sorry,
um,
I had
you can share your screen.
yes, if this is the correct. Can you see my screen?
Yes, there is no problem. You can start.
Okay. Thank you very much. So my name is Nikolaos Katsoulas, and I'm coming from the University of Thessaly in Greece. And I will present you the work with the title In-Depth Study Across Various Disciplines of the Agri-Food Retail Chain on Sufficient, Safe and Healthy Food. This work was carried out with the authors that are shown here in this slide, and is carried out in the frame of European Horizon Green Deal project, the PEST New project, that has a title Testing and Demonstrating Systemic Innovations in Support of the Farm to Fork Strategy. So in the frame of this work, we are trying to bring under systemic innovation novel digital and space-based technologies and combine them with different agroecological and organic practices that are already in a high TRL level, let's say from TRL level, technology readiness level from 5 to 7, and demonstrate them in practical, in commercial conditions, so that a novel circular economy food production system is developed and demonstrated. These demo sites include aquaponic systems, hydroponic systems that apply the circular economy concept, and of course open farm, open field systems. And our scope, our objective is to reduce the dependence on hazardous pesticides, reducing the losses of nutrients from fertilizers, in order to obtain a zero pollution water, soil, and air system with the ultimate use of fertilizers. Some technologies that are developed in the frame of this project are listed here. And we have an artificial intelligent robotic trap, which is capable of taking photos from, taking images from insect traps, and then recognizing the images, the insects that are present in the trap, and counting them, and giving an indication to the growers on when they have to take some action. And it suggests also, in the frame of the project, we are going to suggest what type of actions we are going to have. We are suggesting also and demonstrating an Earth observation system where satellite images are used in order to detect if our system has any problems related to fertilizers or insects. And then again, we are going to suggest what kind of actions the grower may have to do. We are developing an autonomous robot that is going to be used inside the greenhouses in order to monitor, again, the presence of insects or fungi in the greenhouse, and apply pesticides that are developed in the frame of the project. Also, the aquaponic and hydroponic systems are equipped with online portable analyzers, nutrient analyzers, in order to perform real-time nutrient solution analysis, and then give this information to the growers on how to manage the hydroponic nutrient solution that is used in their farm. Finally, another technology that is used is the development of a flow cytometer for microalgae and bacteria monitoring. And this is also connected with the system that we are developing and testing for the production of microalgae using the drainage solution from the hydroponic systems that are used in the frame of the project. So this is a project that has many disciplines and reveals the dynamics, practices, and awareness among agricultural producers, agricultural growers, farmers, and merchandisers, with a focus on the targets of European Union related to farm to fork strategy to support secure food supply in a sustainable way, a reduce of chemical pesticides, elimination of their use, development of organic agriculture and relevant products, and a use of digital technologies in order to aid in the management of agroecological systems. So in order to start from the lower level, from the growers and the merchandisers related to the agricultural products, we did a survey in the frame of the project on agro-retail suppliers of a large supermarket in Greece, of Masoutis SA. And this was done using an online questionnaire. The analysis was done using Microsoft Excel sheets, and we did an assessment of the current food safety protocols and readiness of suppliers for the targets of Green Deal towards 2030. So the questionnaires were directed to growers and to merchandisers, and we received 25 replies from growers and 75 replies from merchandisers around Greece. And here we can see some of the results that we obtained during this survey. So first of all, the question was related to the knowledge if the growers or the merchandisers are certified and related to their production and their products. And the question was if they were certified according to Global GAP, to Agro 2.1 and 2.2 standards, or ISO, or any other standards. And we can see that most of them had no certification, but a large part of them had also a high certification from Global GAP. That is a relatively wide standard and does not cover many aspects of the Green Deal targets. And the same figure almost was shown from merchandisers that are also using the Global GAP standard. So another question was how frequently is testing on the products that are received by the merchandisers, and we can see that only 15% of the participants do a residual analysis, residual related to the chemicals used in the products and any residues remaining in the products. 64% of the participants replied that proceed to a residual analysis, but not to all the production that they produce. In the question, if they conduct audits, if the merchandisers conduct audits to the producers, we can see a clear yes, that is, the merchandisers have a close look on the operations that the farmers do and know what exactly they are applying. And these audits are relatively frequent. 40% is every 6 months, or 40% every year, and 22% about is in less than 6 months frequency. In the questions of related to the information about the products or the active substances that the producer are using, again, we can see that the merchandisers know very well what the growers use in order to produce their products, and they also know the frequency of application of these products. It is clear that they are having a close relation with the growers. In relation to the problem of using specific plant protection or fertilizing products, and if they are willing to apply synthetic biofertilizers, the most significant problem is the high cost of these products, although they are willing to do it. And a large percent of their opinion is related to the ineffectiveness of these products. So we have, if we want the growers to use more bio-based fertilizers and pesticides, we have to reduce the cost and increase their efficiency of application and effectiveness in application. In the question related to the which are the most important factors to discourage you from using a higher proportion of biofertilizers, we can see that is the high cost again and the ineffectiveness of these products. So again, we have to reduce the cost and increase the effectiveness of these products, because the growers would like to use biofertilizers or organic insecticides.
Sorry, your duration is finished. Please conclude.
I will conclude in 2-3 slides. Thank you. The growers would like to convert to organic, but they are considering in relation to the vulnerability of their crop to the pests and diseases, and to the high cost of the production of these organic farming systems. They are aware and they use smart devices in relation to the technology that are used, and some of them also use drones that can increase the efficiency of the information technologies that are available. Going to the conclusion, then we can say that most of the participated producers lack any form of certification. Most of the merchandisers are certified to ensure food safety, and significant influence of the merchandisers and standardizers on producing regarding pesticides application is found. Producers are willing to apply, but they say that it is high cost and inefficient to use some of the pesticides, organic and pesticides and fertilizers that are available, and are also willing to use the technologies that are available. In order to increase organic farming up to 25%, that is the target for European Union for 2030, we have to provide the growers with knowledge to grow sufficient organic products, and with new technologies and innovation actions. And this is the target of the Pest New project, that targets to increase this organic farming area in general. Please register to our Pest New digital platform in order to receive more news and be aware of the technologies that are developed. Thank you very much for your attention.
Thank you very much for your presentation. Dear participants, do you have any questions about this topic? I guess there are no questions. We can go on with the next paper. The title of the paper is Performance Testing of Multicast to Unicast Conversion Mechanism in Wi-Fi Environment. Are the authors here?
Yes, I'm here.
Okay, you can share your screen.
Let me just share my screen. Okay, do you see the presentation?
Yes, we can see.
Okay. Okay. Let me just check one more time. Do you see the presentation now in the presentation mode?
Yeah, no, it's not in the presentation mode.
Okay, then let me. Okay, now it should be visible.
Yes, now we can see.
Okay, thank you for the opportunity to present this paper, and I will start with a short introduction. So maybe you heard about the different types of communication in the network. So we have just shortly unicast, multicast, and broadcast communication. Unicast is one-to-one, so two computers communicating together using any protocol. Broadcast is mainly for discovering the network, like DHCP discover messages or ARP messages to discover layer 2 addresses. And multicast is mainly used in video streaming, so because it's more efficient than unicast. In short, you have a server that is streaming multiple streams, like for example 100 TV programs, and if we use only unicast traffic, then it would be one stream per user from the server directly, which is not efficient. So that's why we have multicast communication, which is much more efficient for the network. So you have only one stream from the server instead of multiple streams depending on the number of users. So if there's 100 users, you will have 100 streams. So the network must be also configured for this multicast traffic so that each network router knows how to answer requests from the customer, from the client, to send multicast traffic that the router already knows about. Okay, so this is just shortly about these types of communication. So the topic of the paper was how to actually to see what will happen if we use multicast communication through the wireless network, how the performance would be. So in modern Ethernet networks, each end device, each computer is part of one collision domain, so its own collision domain. So multicast and broadcast and unicast traffic can be sent at maximum rates. In wireless environment, however, all endpoints are part of single collision domain, which means that all the broadcast and multicast is visible by everybody. Well, this is by default. So this is a problem. And because of this issue, the nature of this traffic, and there is practically no mechanisms that are standardized, the multicast and broadcast traffic is treated the same, and it's sent at the lowest possible rate. So because there is no mechanism of acknowledging that something was received or not. Only unicast traffic, unicast frames are acknowledged in wireless environments, so they can be sent using different speeds, different transmission rates, and so on. And then this also reflects on the energy consumption, which is, of course, very important if we are talking about mobile phones and laptops and so on. So wireless communication is very demanding on the battery if you are using only wireless for video streaming and so on. In development of standards, these challenges and some others are not addressed like a standard, but it's left to specific vendors to develop their own solutions. And this will be only more challenging as we go into the future because of multiple new devices that are connected over wireless network in local area networks, like, for example, campuses, hospitals, and so on. So the more devices are connected, the problem will be more evident, especially if we want to actually use a multicast type of communication, for example, for managing some swarm of devices in the same manner that are part of the same multicast group, which is in wired network normal. So then it will be a challenge because, as you will see, if we connect more than 4 devices and using multicast traffic, it practically becomes unusable network. Okay, so this was our test environment. So we connected wireless LAN controller, which is managing the access point. We have some server that streams multicast traffic, and then some wireless devices like laptops that can actually see this traffic. This was just the right side of the screen is the frequency spectrum of our test environment, because this also is important. We tested this in an environment which has some other access points. So this is how it looked like. First, we tested with the no conversion, because vendor solutions are proprietary, but in principle, they actually are doing conversion between multicast traffic that is coming through the wired network and convert this traffic into unicast traffic and then send it on to wireless network. So the testing was done using iPerf version 2 tool, sending generic UDP traffic, which is normally how IP TV is sent in any video stream. We set it to 20 megabits per second to be able to watch full high definition movies. And then we tested how this is going to affect the network. So without multicast to unicast conversion, the loss was averaged 85%. You can see on this screenshot here, the rightmost part is percentage of lost datagrams, so it's practically almost unusable, and the speed was only 0.5 megabit per second, and jitter was also considerable. So this is without conversion. When we did the conversion, so we enabled this mechanism of converting multicast to unicast traffic and done the same test, then the practical data loss was negligible, so it's 0%. None of the data was lost, and we could have used all the bandwidth that we wanted, so 20 megabit per second. Also, the jitter was practically negligible. But as we added more Wi-Fi stations, so for example, this is with 4 Wi-Fi stations in total, then it's clear that this mechanism is not adequate. So it will work when you have 1 or 2 stations, but if you have more than that, practically the transfer rates are very degraded, and in this case it was 28% in average of datagram lost. So this is clear that something else should be done in order to solve this issue of multicast traffic over Wi-Fi networks. So this is in short summary of this test. So without multicast to unicast conversion, 85% loss, and with multicast to unicast conversion up to 4 clients, it worked fine. And then after we added 4th client, then the network degraded practically to be unusable. Any other client that we add, it will be just even worse. So one direction in future should be, or could be, a mechanism that is confirming the frames that are not received in multicast, so not acknowledging every frame, but only ones that are not received. But then it would have some other challenges because of the latency and so on. So some buffering mechanism should be used. But this paper showed that actually our testing showed that practically these mechanisms that are used, unicast to multicast, are not practically usable for any considerable size of the network. And also these mechanisms are actually only available on some higher end devices, which are much more expensive than lower end devices. So practically, if you want to use multicast to unicast conversion in wireless environment in school, for example, in our school, we should buy maybe 200 access points with this capability, which is considerable amount of money. So this is also not something that is maybe practically in all cases. Okay, so this is from my side. Thank you.
Okay, thank you very much for your presentation. Do you have any questions about this topic? Yeah, I guess there are no questions. The title of the next paper is Facial Features Recognition Based on Their Shape and Color Using Yellow V8. Are the authors here?
Yes, I'm here. Can you hear me?
Yes, we can hear you. You can share your screen.
Okay. Can you see the screen?
Yes, we can see. You can start.
Yeah. My name is Dafar Al-Ubaidi. I'm a master degree student at Gaziantep University, and I will present the paper Facial Feature Recognition based on their shape and color using YOLO V8. The human face is a wealthy source of information with distinct features such as the eyes, nose, and mouth, offering a wealth of data. Facial feature recognition algorithm leverage this wealth of information to distinguish one person from another, making it a powerful tool with many applications, especially in security aspects. Even more, a person's personality trait can be predicted from their outer appearance according to physiognomy, as each shape of facial feature can tell a lot about person's personality. Physiognomy is separating person true nature from their outer appearance. The Chinese, Egyptian, and Greek were among the first civilization to think of the concept of being able to see person's personality through their face. In this study, a novel dataset created for facial feature recognition based on their shape and color, specially designed for the YOLO object detection models. Existing datasets are unsuited for practical facial feature recognition because they typically lack the necessary bounding boxes and annotation, as it annotated for the face recognition in general. Therefore, a face image for both gender were neatly chosen, as the face features are apparent and do not have face occlusion. The final dataset consists of over 2,000 images and with over 10K annotation, with 6 classes, namely blue eyes, brown eyes, round nose, rounded eyebrows, pointy nose, and straight eyebrows. The dataset then employed in the AL version of the YOLO V8 object detection model. Also, we proposed a modified lightweight version of YOLO. Why we choose YOLO V8? The YOLO is the most popular real-time object detector due to its lightweight network architecture, effective feature fusion method, and accurate detection result. The newest and the most advanced YOLO model is called YOLO V8, issued in January 2023 by Ultralytics, the same company that built YOLO V8. YOLO V8 offered
I guess connection is lost.
I think I lost my. Are you hearing me?
Please share your screen again.
Okay. Is it visible now?
Yes, please go on.
The original YOLO V8 model has 365 layers with over 43 million parameters and gradient. Reduced the depth and the width of the network to 0.1%. Also, the stride of the second and third convolutional layer of the backbone set to 1 to increase the feature extraction. The resulting model has only 211 layers with over 20 million parameter and gradient. It's a lightweight and require fewer computation resources, resulting in a faster training time. To provide transparency in the evaluation process, our version of the YOLO V8 algorithm examined with the same parameter, with input size of 640, and the algorithm trained for 200 epochs, with early stoppage of 25. The byte size of 60. Also a detailed evaluation result based on precision, recall, a phone score, and the mean average precision at 50 and 52.95 are presented in the next slide. Here we can see the recall, precision, a phone score, and the mean average precision for all versions of the YOLO V8. You can notice that the small version reaches the highest MAP, which is the mean average precision. Here are the detailed class mean average precision for all the version of the YOLO-V8. This figure shows the comparison of the modified YOLO-V8 with the last 5. We can see here that the mean average precision of the nano model is reaching high as its percent is 69.3. But for the MAP at 50, the modified version has a remarkable percent of 91.3. Here are the recall, and this is for precision. This is for every class for the YOLO-V8 version and the modified YOLO-V8. You can notice the modified YOLO-V8 is reaching higher with the classes related to the shape like the nose and the eyebrows as it increases its performance. That's it. Thank you.
Thank you for your presentation. Do you have any questions? Okay, I guess there are no questions. Let's go on with the next paper. The title of the paper is Historiographical Study of the Evaluation of the Geocoding Systems with Equiangular Tessellation. Are the authors here?
Yes,
Okay.
I'm here.
If you are ready, you can share your screen.
Thank you for the opportunity to present my paper, our paper, Historiographical Study of the Evolution of Geocoding Systems. I am Pavel Petrov, University of Economics, Varna, Bulgaria. Nowadays, geolocation coordinates are obtained directly from devices supporting one or more of the global or regional navigation satellite systems, GPS, Galileo, Beidou, GLONASS, QZSS from Japan, NAV, IC from India, etc. In this regard, it is noticed that the volume of data related to geographical location is constantly increasing. This is due to the widespread use of smartphones and other mobile devices with built-in GPS receivers, vehicles with automatic navigation, drones, Internet of Things type devices, and so on. So the popularity of services as geotagging, geomarketing, geofencing, and others is growing. All these tools, devices, and services generate a huge amount of data that must be processed in timely and efficient manner in order to improve decision support. There is a lot of systems and geocode formats used in geographic information systems to represent the location. A pair of real numbers, longitude and latitude, it is classical coordinate system. There is another systems. For example, our research shows that natural area code developed in 1994 is a kind of beginning of modern geocoding systems with equiangular hierarchical tessellation. By the way, there is taxonomy, official accepted taxonomy of so-called discrete global grid systems. It is an international standard of international standard organization. And it is interesting that the natural area code system is also mentioned in an ISO standard 19145 called Geographic Information Registry of Representation of Geographic Point Location. And over time, the interest on this system has been maintained by several authors. Other popular systems which we investigate is the patent from Microsoft patent from 2003, GeoHash geocoding system from 2007-2008. What is interesting for the geohash encoding is that it is currently used in a number of relational database management systems. For example, PostgreSQL, MySQL, Redis, MongoDB, Lucene, Elasticsearch, Solr, Cassandra, Memcached, Couchbase, HBase, DynamoDB, and so on, many more. So it is very, very popular these days. There is another systems which didn't fail to be implemented widely in practice. Also, there is some geocoding system especially designed for countries for Africa, and these systems, they are developed from startup companies. So these companies receive some kind of funding to do their job. And these systems, they are not so much popular around the world, only in few countries in the continent of Africa. Also, in our paper, we overview the Google Open Location Plus Code system, the Microsoft Quad Keys system from 2008, S2 Geometry also from Google, H3Geo from Uber company, and so on. In conclusion, we can say that this geocoding systems, which we research, investigate in our paper, they are all equal angle tessellation systems. There is a new proposal for an equal area tessellation. It has recently emerged. In these systems, the surface area of all cells with the same string length is equal. This is accomplished by transforming the latitude with the arcosine function, while the longitude remain the same. We hope that these systems will prevail in the future. So thank you for your attention.
Thank you very much for your presentation. Are there any questions? Okay, there are no questions. The title of the next paper is Multi-Spaces Ensemble Architecture for Text Authorship Classification. Are the authors here?
Hi, yeah, I'm here.
Okay, you can share your screen.
Yeah, one moment. Okay, do you see my screen?
Yes, we can see, and you can start.
Okay, thank you. So hi once again. So my current topic is multi-species ensemble architecture for text authorship classification. So Authorship identification is important for several reasons. First of all, it assists in validating the information source and ensuring that the information is reliable and trustworthy. Particularly in the age of fake news, this is crucial. Second, understanding the author of piece can assist readers contextualize the content they're reading by revealing information about the author's training, experience, and potential biases. Last but not least, revealing the author of a piece enables readers to provide due credit and recognition to the author's effort, which is crucial in academic and professional contexts. Identification of the author of any book is crucial for proving its legitimacy. So methods for identifying the authors of a given text are known as authorship identification methods. These days, both manual and automatic approaches are available. Automatic methods include text classifiers used in machine learning, and text identification techniques help with author classification and feature extractions. Yeah, and the hybrid classifiers are expected to be more successful than individual methods, and they are straightforward combinations identifying the author of the text based on a distinct style, lexical features, and other characteristics. This consists of some of the numerous known methods in the form of an ensemble. So the paper details the finding of the experiments in which the efficiency of machine learning models with regard to the issue of text author identifying utilizing various approaches and methodologies was investigated. So some words about the background. So to provide a reliable algorithm that correctly identifies the author of a given text or document is a formal problem statement for author identification. Different writing styles should be distinguishable by the algorithm, which should also include elements like syntax, vocabulary, and punctuation. The objective is to develop a trustworthy tool that can be applied to a variety of tasks, including content curation, plagiarism detection, and forensic analysis. So the issue is complicated by the fact that authors can alter their writing styles either consciously or unconsciously. And the problem is formulated as follows. So suppose we have a text set of text T of authors A. We know that authors of some text of subset T, so we have corresponding list of authors and text the training sample L. And the goal is to create a classifier that is a function that determines the true author of an arbitrary text from the set T. And so for base classification methods, the technical classifying text into determined groups is called text classification. And rule-based approaches utilize manually developed criteria to categorize the text, whereas statistical approaches make use of mathematical models to calculate the likelihood that a document falls into a certain category. Support vector machines, decision trees, and neural networks are examples of machine learning algorithms that can help to classify our data. And now some words about ensembling. So the preparation of the text for classification of the end process is an important stage in the text classification processing. Tokenization, supports elimination, stemming, and minimization are a few often used techniques. So, and this preparation is the first stage of our ensembling classification. And the second stage is encoding. So, and two common categories of encoding techniques are binary encoding and count encoding. So after that, different type of techniques and their combinations may be included in the classifier's block of methods after preprocessing and encoding. The outcomes of the procedures themselves can also be taken from the voting blocks and compared to the outcome. So the output of numbers-based classifiers are combined in ensemble classifiers using a variety of voting mechanisms. Voting mechanisms they are often employed include probabilistic voting, weighted voting, and majority voting. So now about current process. So what can be improved in classifiers and ensemble classifiers in particular. So we have several growth points, and the first one is feature selection. So deciding which elements best capture on and also writing styles can be challenging. It might be difficult to decide which qualities are the most useful, but choosing important and discriminative ones is essential for precise author strip identification. And the second growth point is writing style evolution, because writing style can vary over time as a result of variety of different causes, including personal development, education, or different interests. Yeah, and as important component to improve and to include in our potential classifier is quantum component. So it's quantum inspired component that can be used in classical computations. So let's document can be represented as superposition of hidden states. Then we can create special wave function where the coefficients correspond to the components of the vector x. Then we use special Born rule from quantum mechanics to compute the special quantum components U. And finally, we use special equations that define the inner component of the neural network. And after the normalization applying, we receive our Y values, and we define the transformation from X to Y. And finally, about our supposed ensemble approaches. So mainly it has much in common with other ensembling, but the first remarkable thing is that is use special quantum component, and the second one that we divide our text features into different subsets of features, and each of these subsets is analyzed by appropriate classifier. And after that, we summarize the result of classifications, and after voting, we receive our result. So this figure shows only a general scheme. So the number and combinations can be arbitrary. Also, this multi-criteria approach should allow for increased classification accuracy, which maintain an acceptable level of performance. Although there are methods that can achieve high accuracy, they are often quite resource intensive. But in this ensemble, people focus on relatively resource neutral methods as components. And as mentioned above, there are several types of ensemble voting, and for our model, we choose
I guess connection is lost. Let's wait him to come again. Can you hear me?
yeah.
Please share your screen again.
Actually, yeah. Okay. Do you
Okay, you
understand?
have, by the way, you have just 1 minute to conclude your work, okay?
Yeah, just 2 slides left.
Okay.
Yeah. So in the end, it's worth noting that we primarily limited ourselves in our choice of methods, without considering more cumbersome ones. As a rule, they show noticeably high accuracy, but requires much more resources. So the point is precisely to achieve the highest possible accuracy at the conditional load cost, and it was achieved in our supposed classifier. So using complex features and ensemble approaches, high quality training data is so on all necessary to improve this document classifier. And with this improved classifier, we can better identify instances of different kinds of borrowing, like as mentioned above, plagiarism detection, and so on. And finally, we demonstrated classification method is a promising direction in the field of data analysis, and this method offers a more efficient and accurate way of classifying data compared to traditional ones. So the method's success in classifying is a promising indication. And I'd like to add the direction of the future research is forming different methods, comparating schemes, voting improvement algorithm, and methodologies that will propose the necessary solution for the regional data. At the moment, the proposed classifier is being validated an application system for identifying borrowings in student works. Yeah, and that's all. Thank you for attention.
Thank you for your presentation. Are there any questions about this presentation? Okay, there are no questions. Let's go on with the next paper. The title of the paper is Embroidered Patches for Seamlessly Embedding Sensors in Smart Textiles. Okay, we can see your screen. You can start.
Okay, thank you, dear audience. I am glad to present you our paper, Embroidered Patches for Seamlessly Embedding Sensors in Smart Textiles. My name is Daniela Sofronova, and I'm from Technical University of Sofia, Bulgaria. I am going to start with some brief introduction. In the past, embroidered patches were used to cover up holes and tears and clothing. Today, they are widely used for advertising trademarks in workers' uniforms to indicate a name or position, or in clothing to add decoration. Unlike traditional embroideries, embroidery patches could be placed on finished clothing items at any time in any place according to the user's desire. Another advantage is that the embroidery patches could be produced from fabric scraps or old cloths. Fast fashion and overproduction lead to serious global environment problems. Actually, the fashion industry is the third largest industrial polluter in the world, creating up to 10% of the global pollution. The textile manufacturing and consumption systems are included in the Circular Economy Action Plan of the European Commission from 2020 as a priority product value chain. That's why it's important to find a way for customers not to throw away their clothes, but to find a way to give them new life. And embroidery is one of the options for upcycling old clothing items. An important feature is also the embroidered patches to be applied in e-textiles. One possibility is to be used as wearable antennas produced with conductive threads. Another option is to hide or incorporate sensors for different types of monitoring. And in the next 6 years, the embroidery patch sales are expected to grow because embroideries create personalization of the cloths. And due to the lack of publication in this area, it's important to consider the production technologies of embroidery patches and the possibilities of their application in e-textiles. Therefore, our paper aimed to analyze the weaknesses and the strengths of each production technology of embroidery patches. An important feature when digitizing embroidery patches, the same rules are followed as the standard embroideries, but they must be designed according to the patch type. Embroidery patches may have the design presented here on this figure above. For both types, the contour one is done with satin stitch, giving the embroidery a finished look, and inside of the area could be filled or not with stitch rows. And here you could see also some form of patches that could be different. They could have simple geometric primitives, or they could be more complicated. We could have a full covering with stitch rows or not, and we could use non-woven instead woven or a knitted macro structure, and so we could also use application technique. Digitization of the embroideries could be done from the design developed on the paper, or we could use a digital one, and in this case the first 3 steps are omitted. When the digital image has a higher resolution and the inside objects have uniform colors, the digitization could be done almost automatically. Otherwise, objects are drawn one by one, and they should be arranged in a certain sequence according to the colors and machine needle quantity. The type, parameters, and color of the stitch rows are assigned to each object. Embroidery patches could be used with standard technology, or we could also use the applique technique. The steps are quite more, but when we using pre-cut samples, it could be stick firmly on the fabric. And by using technology with backing materials only, many of the steps are omitted. And all described technologies have been experimentally tested for designing of embroidery patches for creation of e-textiles. An embroidery machine, Genome MB4 with 4 needles and 1 head was used for embroideries, and their digitalization was made using Digitizer Pro software, and polyester and viscose Madeiros embroidery threads with linear density of 135 were applied, and some important criteria was assessed. The possibilities, the patches to be made of old recycled clothing or textile, and the possibility to use small pieces of fabric with different macrostructure, woven, knitted, or non-woven, and the stability of embroidery process, the necessary to use additional consumables, and the ease cleaning of the edges of the embroidery patches, the machine time, and the possibility to obtain full coverage with stitch rows. And here you could see some examples. Just a second. I could not see my examples. I don't know why. And in these tables, we have summarized the strengths and weakness of each tested methods for design and manufacturing of embroidery patches according to this evaluation criteria. And here on this slide is presented an example of embedding a body temperature sensor in an embroidery patch intended for children's head. The created textile could be used to continuously measure the body temperature of the babies and young children during their illness. And here you could see also the head and the created intelligent textile systems. And here is the graph below. Shows the example results of the 2 hours continuous temperature measurement of 6-month baby. Embroidery patches could be effective use in the design of textiles. The patches can cover height sensors or be used as antennas. They also assure easy maintenance as they can be removed before and reattached after washing the garments. And the unlimited aesthetic variety of the embroidery patches can satisfy the requirements of different age groups. An additional advantage is that they can bring tall clothing items to new life by covering up holes and tears. And the reverse approach could also be applied by using the clothing piece as embroidery ground fabric. And this is excellent solution to the ecology problem caused by the fast fashion industry. And another advantage of this technology is the level of autonomy of the embroidery process by using specialized machines which improve the complexity of produced design, their aesthetic value, speed, and cost. And finally, the workflows of methodologies and for digitalization and production technologies were presented. They are approved by producing a couple of samples. Some evaluation criteria were defined, and according to them, the weakness and strength of different production technologies were summarized. The authors would like to thank the research and development sector at the Technical University of Sofia for the financial support. Thank you for your attention.
Thank you for your presentation. Do you have any questions about this topic? Okay, as I can see, there are no questions. The title of the last paper is Generating and Evaluating City Building Facades Using Artificial Intelligence. Are the authors of this paper here? I guess they are not here. Dear participants, thank you for your scientific contribution to the Congress. Now I am ending the session. Thank you.
Thank you very much.